So before we move on to cube roots, I want to look at one more type of square root expression that we run into all the time and that we also want to know how to simplify. And that's the case when we have a fraction underneath our square root or a square root inside of our denominator. So in this example, we're trying to simplify the square root of 1 over 8. And so in order to do this, we are going to use our product property for radicals, but we're really going to use it in a slightly different way, because I think it's easier to view this expression underneath our radical as a quotient instead of a product, but it's really the same thing. So kind of similarly, we can also write a quotient property for radicals, although it's the same thing, so we're not going to give it a new title. But if we have something like the square root of x over y, we can break that apart as the square root of x over the square root of y, basically just evaluate the numerator and denominator separately. But of course, we have to still make sure that x and y are both positive. And also, in this case, y cannot be equal to 0. Oops, let me fix that. I meant to write y cannot be equal to 0 because we can't have division by 0. So applying this alternative version of the product property for radicals, or really like the quotient property for radicals, allows us to rewrite our original expression, the square root of 1/8, as the square root of 1 over the square root of 8. And well, now we can evaluate the square root of 1. What number do we have to raise to the power of 2 to get 1? Well, that's the number 1 itself. And in the denominator, we have the square root of 8, which is a non-perfect square number, but we can simplify it. Using our earlier process, but just now in the denominator, we can think about breaking apart the square root of 8 as the square root of 4 times the square root of 2. And now this is a much better spot to be in because we can evaluate part of this radical. After evaluating that square root of 4, our expression ends up being equivalent to 1 over 2 times the square root of 2. However, we're not quite done yet. And the reason we're not done yet is we don't want to leave our radical expressions in a form where we have radicals in the denominator. And so now we have to do this process that is often called rationalizing the denominator. And the way we're going to do that when we just have products involving square roots in the denominator is we're going to introduce the missing factor to the denominator that makes the denominator involve a square root of a perfect square. So to think through that for this example, we're currently working with the square root of 2 down there, but we need to introduce another factor to the square root of 2 that makes it a perfect square. And for square roots, this will always just be the factor itself. So we can introduce another factor of the square root of 2 in the denominator. But we have to be careful about how we are manipulating an expression. When it comes to manipulating an expression like this, we can really only add and subtract by 0 or multiply or divide by 1. And so what we're going to do here is multiply by 1 in a very fancy way by writing this factor of 1 as the square root of 2 over itself. So now we're just multiplying our original expression by this fancy form of 1. In the numerator, 1 times the square root of 2 is just the square root of 2. And in the denominator, we have this first factor of 2 that gets multiplied by the product of these other two factors of the square root of 2. And kind of working our product property for radicals in reverse, we can put these two square root factors back together, and that becomes the square root of 4. But the square root of 4 is now a perfect square, and we can take that square root, and that gives us another factor of 2. So our expression then looks like the square root of 2 is still in the numerator. In the denominator, we have 2 times the square root of 4, but that square root of 4 turned into another factor of 2. And now we can just multiply those two factors of 2 in the denominator together, and we end up with our final answer in its most simplified form. And that final answer is the square root of 2 divided by 4. All right, so we've seen a few different examples now of simplifying and evaluating these square root expressions. And we want to have a very clear idea of what it means to be simplified for one of these expressions. And so here I have a summary of how I would describe a radical expression, or at least a square root expression, to be in its simplified form. In order for a square root expression, like the latest example we have here, to be in its simplified form, it should have all the perfect square factors factored out and reduced, and there also should be no roots, like square roots, in the denominator of the expression. And so if we go back through our work for simplifying the square root of 1 over 8, we can see we're kind of accomplishing all these criteria. First, we used that quotient or product property for radicals to break things up to make them easier to work with. Then we factored out the perfect squares and reduced them. But then we had a square root left in our denominator, so we had to figure out how to rationalize the denominator. After we rationalized the denominator and simplified a little bit further, just by combining factors together, we ended up with the square root of 2 over 4. That is simplified. It's equivalent to the square root of 1/8, but it has all the perfect square factors removed or factored out and reduced. And it also has no radicals, no square roots or anything like that in the denominator.